For the last 3 years, the AI industry has mostly followed one expensive idea: bigger is better. But is that true? Major AI labs are spending billions of dollars on huge data centers to train bigger and bigger models. But Baidu's release of ERNIE 5.1 challenges that way of thinking, both financially and strategically. Instead of building an even larger system, Baidu claims ERNIE 5.1 can compete with some of the world's most capable AI models while using far less computing power. This visual shows why that claim matters. Compared to similar frontier-level models, ERNIE 5.1 reduces its total parameters to about one-third, cuts its active parameters during inference by about half, and required only around 6% of the pre-training compute cost to build. In simple terms, Baidu is saying it found a way to make a powerful AI model much cheaper to train and run. If that holds up, it shifts the industry's focus from pure size to smarter design. The secret behind that 6% pre-training cost is that Baidu did not train ERNIE 5.1 completely from scratch. Instead, it pulled ERNIE 5.1 out of its larger 2.4 trillion parameter model, ERNIE 5.0. This architecture shows Baidu's multidimensional elastic pre-training framework. On the left side, the system uses elastic depth. This lets the model adjust how much work it does, using deeper processing for harder tasks and lighter processing for simpler ones. In the center, elastic width lets the model pull from different groups of specialized experts so it can use its resources more efficiently. On the right, elastic sparsity helps the model activate only a small number of those experts at a time, which can dramatically lower costs. This once-for-all strategy means Baidu can pay for one massive pre-training run, then carve out a smaller, more efficient model that fits a specific computing budget. Baidu is positioning ERNIE 5.1 to compete with major AI models like DeepSeek, Anthropic's Claude, and Google's Gemini. This leaderboard crop from Arena Search shows Baidu's strongest public evidence for its live search and retrieval abilities. ERNIE 5.1 is ranked number 4 globally, sitting directly between Claude Opus 4.7 and Claude Sonnet 4.6 search. This workflow also points to a bigger shift in the AI industry. AI is moving toward digital workers, systems that can search, use tools, check their own work, and adjust as they go. These benchmark charts measure those exact digital worker skills. On TalBench, which tests how well a model handles messy company documents, and Spreadsheet Bench, which tests real-world Excel-style tasks, ERNIE 5.1 scores higher than DeepSeek V4 Pro. Looking at these tests, it seems Baidu designed ERNIE 5.1 to work especially well as a productivity tool and task executor. But when you aggressively shrink a massive AI model to save money, trade-offs are almost guaranteed. This highlights 3 important gaps. First, in practical coding, ERNIE 5.1 can struggle to keep track of everything across complex scripts. That can lead to answers that look believable but do not actually work. Second, its general world knowledge appears thinner when it does not have live search available. Third, it falls behind on deeper, multi-step research tasks, where the model needs to work more independently. So, targeted efficiency creates a seesaw effect. The model performs well in specific workflows, like reading spreadsheets and handling business documents, but it still looks more fragile when used as a general-purpose answer machine. This evaluation gives us an important reality check. The 6% pre-training cost claim is impressive, but right now, that number depends on Baidu's own internal comparisons and testing assumptions. Also, Arena leaderboard rankings depend heavily on the kinds of prompts users submit. That means these rankings are useful signals, but they are not the same thing as a full, independent technical review. Even with those caveats, ERNIE 5.1 suggests the race for AI dominance may be changing. It may no longer be just about who has the most data center chips. It may also be about who can build the smartest and most efficient AI architecture. The real test for ERNIE 5.1 will come when developers around the world try to use it in everyday production workflows and see whether these promised efficiency gains actually hold up. That brings us back to the main idea on this. Frontier-level performance may not always require frontier-level compute. If these efficiencies hold up under independent testing, it could lower the cost of entry for the entire AI industry.